Okay, we are preparing to live stream. Welcome everyone who's joining us tonight. Dr. Gareth Dyke is here with us as always. Dr. Dyke, thank you so much for coming again and again to share your expertise. How are you doing today?
I'm doing great, Scott. Thank you very much. I'm doing fantastic. It's almost Christmas, so I'm feeling very festive, and I hope all of our attendees also are getting in the Christmas spirit. I've got my Christmas shirt on today, so welcome everybody to our Bentham Sidetrain event. It's going to be good, hopefully.
Fantastic. We've got people coming into the room already, so we'll give just a minute or so for all of our guests to come in and join us. I'm going to set up the chat window now so that everyone is able to share their thoughts with us in the chat window. And keep in mind, we also have a Q&A panel there, so you can ask questions and we will handle your questions at the end. So feel free to type any questions that you might have into the Q&A window, and we'll try to get to as many questions as we can. And if we can't answer your question within the event today, then we're happy to catch up with you and get back to you after the event. Isn't that right, Dr. Dyke?
Absolutely. Everyone attending gets a recording. Everyone attending gets a certificate. If you have questions or comments, or you just like to let us know where you're from, do put some comments in the chat or in the webinar Q&A. Absolutely. Be great to learn like where our attendees are from today. If you'd like to let us know where you are from, that'd be great. And we'll have a Q&A session at the end of our short presentation today. I see, yes, Hiba's letting us know that she's joining us from Dubai. Please get in touch. I'm in Budapest. Scott, where are you?
I'm in central Tokyo, and it's a very crisp winter evening here. And yeah, oh, we've got friends coming from all over the world. We've got Algeria, India, Tanzania. Fantastic, fantastic.
Absolutely great. Absolutely great. We're also live streaming this event on LinkedIn. So if you're listening to us on LinkedIn Live, welcome to this Bentham Sidetrain webinar. Go figure! Some secrets of statistics and tips and tricks for data presentation. Right, Scott?
Yeah, this is something we often get asked about from researchers around the world is how to best present data. And it's a very broad topic. So obviously we can't cover everything in just one event, but hopefully we'll be able to cover some of the most important points, including a couple of ethical points as well to think about as you're choosing to present your data.
Absolutely. Absolutely. 100%. Let's get started by just saying a few things about our sponsor today, Bentham Science Publishers. If you haven't encountered Bentham Science Publishers, do have a look, because this is a fantastic growth publisher with a catalogue of more than 100 hybrid journals and more than 40 open access journals, as well as more than 1,300 ebooks. And you can see all of the fantastic places where Bentham books and journals are listed, including Scopus, Cabell's, and so on. So if you're looking for a great place to publish your next research paper in a journal with a very decent impact factor, up to 7 in some cases, recently in the Clarivate list, Bentham is also happy to have the most robust peer review process out there in the publishing industry. And we've worked for a bunch of different publishers and a bunch of different companies, Scott and I. It is really, really robust, the Bentham peer review process. Editors not involved in the selection of peer reviewers. Peer review only carried out by colleagues with H indices greater than 5. And if you're listening to this and you're a librarian, do give the QR code on the screen a quick scan, because scanning this QR code will give your institution access, 3 months free access to all of the Bentham content, which is absolutely fantastic. If at the end of 3 months you're not interested in continuing, maybe nobody's used any of the content, or you've not enjoyed that free access, I don't know why you wouldn't, but maybe you won't, you are going to be cancelled with no charge. But of course, then you could choose to move your institution onto a subscription. So take 3 months as a free trial just by scanning the QR code on the screen in front of you in this event today. I think we're ready to get started with the main content of our presentation today. Scott will be back, dipping in and out here and there as we go through the presentation. Right, Scott? We've got a few polls and quizzes and bits and pieces to keep everybody entertained and energized. I hope. We should be fine. We should be fine. Let's get started then with this key quote from Paul Arden, which is, the more strikingly visual your presentation is, the more people will remember it. And more importantly, they will remember you. Presentation skills, statistics, analytical skills, data presentation skills are really, really important. One of the areas where you can use AI to help you, but you won't be replacing all of these techniques with AI tools. You're still going to need to do a lot of this yourself, your own techniques, your own data analysis, your own data presentation. So this is very important as a transferable skill for researchers around the world to develop. And so in our presentation today, we're going to talk about 4 quick topics. Topic number 1, things to think about before you begin making your figures. Topic number 2, types of figures and when you might wish to use them. Very important because, of course, lots of papers that get submitted to international journals have inappropriate kinds of figures included in them, and so they get rejected or sent back to the authors and changes are required. We're then going to run through 10 simple rules for making excellent figures, and then a quick bonus section at the end, if you're good, about tables. We'll talk about how you can put together excellent and effective tables for your research articles. So let's go, let's dive in, let's think initially. Topic number 1, what should you think about before making any figures? What considerations should you have in mind before you put a figure together? And don't forget that this is very often, if not most often, the part of article writing that people do first. You've collected all your data, you've analyzed all your data, you're then ready to present that data, making figures, doing analyses, presenting results is often the first part of the publication writing up process. So before you start to put together a figure, have a think. What is the one thing I want my audience to walk away thinking about? You're going to repeatedly emphasize your take-home message in your figures, in your data, in your presentation, and keep it simple, because effective images, effective data presentation convey a single overarching effective message, and that's very, very important. We also ask you, before you begin to put data together, before you begin to present your data in your research articles, to think about your audience. Which journal are you going for? What are the requirements of that particular journal? And who are your target audience? Are there academics, students perhaps? Or are you writing an article that must have a general message? And we'll talk about how to pitch your data presentation to these different audience segments, if you like, a little bit later on when we talk about simple rules for making effective figures. But the key here is to highlight and showcase your results. You know what your findings are, but your readers do not. Don't fall victim to what we like to call confirmation bias, where you're happily going along, analyzing and creating figures and tables, presenting your data. You know what your message is. You know what it is that you want to get across because you're close to the research. You did the work, but your readers do not. So your figures are the window into your research article. This is how you're going to logically guide your readers and show them what you found in your study as we highlight and showcase our results. And of course, your results are results, they're facts. And so in your figures, in your data presentation, in your results section, you talk about just the facts. You don't go off and start interpreting. You don't start talking about what the results might mean in a wider context. That comes later in the discussion section of your paper. So we're ordering our results sections, our figures, our data presentation around primary and secondary outcomes, in the same order, by the way, as you might put those into a method section. If you'd like lots of tips and tricks about how to write an academic article, how to put together the different sections, how to write effectively in English, this presentation that we're doing for Bentham, Sidetrain and Bentham is only one of a number that Scott and I have ready to go. So if you're listening to this and you're thinking, wow, wouldn't it be great to have a webinar for my institution? Get in touch with us at the end. We'd be delighted to send you our catalogue of course content. You're going to state clearly and simply what you found using words and numbers, using figures and tables for those main results and not duplicating information in the text and in the tables. And as we start to think about statistics and data presentation, there's a number of important things to consider. What kind of data are you going to present? What's the main feature of that data? What's the message? How this information is going to be used by your readers, by other researchers, and who your intended audience is. We've already talked about that in a moment, just in an earlier slide. So your tables, your charts, your figures and diagrams should assist with the interpretation of your data. They should be representative. They should not obscure the meaning of the data. And in our 10 rules for putting together effective figures, you'll see how that can be done in a moment. So in terms of data collection and in terms of variables, we break down all of our variables into numerical ones and categorical ones. And this helpful flowchart really breaks down the different areas of data that you might have or intend to collect in your next research project. Your numerical data can be continuous or it can be discrete, subdivided into bins. Your categorical data can be regular or it can be ordered. It can be ordinal. And the different kinds of statistical tests that you'd apply depend upon the different kinds of variables that you're going to collect. Starting point for most analyses. So hopefully you're not thinking about this at the end of the process. You've already got this information in mind as you begin designing your experiment. Because of course, as well, you're going to look at whether your data are quantitative in the form of numbers or counts, data sets with unique numerical values, usually collected using measurements, or whether your data are qualitative. Because of course, in qualitative data, you're describing qualities. Think medical surveys or HSS survey work, humanities and social science survey work, interviews and observations. We have other training, we have other course content. If you're interested in learning the details, the specifics of a particular kind of statistical analysis, you need help potentially with a statistical analysis, get in touch with us at the end as well. We'd be delighted to help you, provide you with consultancy on statistical analyses. So get in touch with us at the end of this presentation as well. We work with a number of partners who are expert statistical analyses. Mars Global, for example. Scott, how are we doing so far? Everything going well?
Great. Our guests are already engaging, Gareth, and thanks to everyone for your comments. And again, just to remind everyone, feel free to ask any questions that you might have for Dr. Dyke. There's a Q&A window. You can pop your questions in there, and we'll get to as many as we can in the event today. But first, we have a poll, and this is on the subject of ethical data analysis. The question is, let me launch the poll here. The question is it ethical to try analyzing your data in many different ways until you finally get the results you want or expect? Do you think this is ethical? Yes. Or do you think it's not ethical?
Yes, there's a word for this, isn't there? Where you like keep running analyses until you find the result that you want. Maybe somebody can share that with us as well. If you're thinking, oh, I know what that is. There's a word for that kind of thing.
Okay, answers are coming in hot. I think all the answers are in. So let's finish the poll and see what the results were. Okay, so it looks like almost a half and half split. Actually, no, but a few more of our guests decided that this is not an ethical practice for data analysis. So 9 of our guests said it's not okay, or 64% that is, and 36% said it is okay. Let's take a look at the answer, Dr. Dyke.
Yes, there it is. Of course. No, it is not ethical. And this is a common trick known as p-hacking, where you keep on running an analysis until you get the result that you want. Don't do it. Be fair, be transparent with your data analyses. Great. Nice one.
There are
Cool.
different variations too. There's data dredging. There's sort of different sort of subtle ways to kind of fudge your data so you get the results that you want. P-hacking, data dredging, and so on. If we had more time, we'd go through some more of them today. But in short, right, it's not ethical to try to nudge your results in a way that makes your study turn out the way you expected. So back to you, Dr. Dyke.
We have another presentation on ethics, research ethics. So if you're interested in hearing that, do get in touch with us. Ethics in research, ethics in publishing. We've seen it all over the last few years, right, Scott? Lots of good things, lots of bad things, lots of experience like helping researchers with their research project design.
That's right. And as we know, I mean, the vast majority of researchers and our guests at these events are ethical people, but we might not know when we're doing something unethical. So that's one of the reasons why we have events like this and questions like this. Yeah.
Fantastic, fantastic. Let's move on swiftly to topic number 2 in our event today, which has to do with the types of figures that you might choose to use in your next research article. And we're just going to run quickly through a number of commonly encountered kinds of data presentation formats, starting with a frequency table. And here you can see a frequency table that breaks down children in terms of frequencies and the numbers in each category. So you've got different hair color types in this example. So the frequencies as well as the relative frequencies are presented here in this table. And a good starting point for you when you begin to think about how to present the results of your analyses is, as we've been talking about in the first section of this short webinar today, how to get your message across. And often that is with a table, even though tables can be a little bit boring. Many people use bar charts. Here's a great example of the numbers of people in each country. Here you can see bar charts, simply a count of the number of things in each category, as opposed to a histogram, which gives you relative proportions. And here you can see an example of a histogram. So have a think about how your data should be presented, what would be the most effective way to get your message across, and do get in touch with us, of course, if we can provide you with any support and any assistance. We work with lots of other colleagues, lots of other companies, lots of other people who are experts, as I mentioned before, at project design, at article development, and analytical development. So if you're thinking about a research question and you're not quite sure how to design an experiment or survey or data collection protocol to get to that question, get in touch with Scott and I, and we can connect you with the right people to help you with your issues. We are research, publication, research solution problem solvers. Here's some pie charts, very commonly used in research publications. Everybody knows what pie charts are. They break down the proportions of things in each category, but they don't have a time axis. So you should never use a pie chart to show historical data over time, and you do not use data in a frequency distribution. These are suitable for categorical data used to show percentages, and so the areas of the pie are proportional to values in each categories. And if you need help understanding a little bit more about how pie charts work, do have a look at these examples here. 45% of people don't understand in this example how pie charts work, whereas 72% do. And some quick things for you to say in your next meeting on the right-hand side. These are reused. If you'd like to know the source, do get in touch with us as well at the end. There's other ways to present data. There's other ways to talk about the results of your study. Timeline infographics like this one, for example, can present qualitative results, can be used to present qualitative survey results, for example. And here's a line graph showing changes over time with the years on the x-axis and the sales up there on the y-axis. A very clear and effective way to present change, in this case, in sales numbers over time. And people do this in a number of different ways. Here you can see some scatter plots presented here on the screen, positive and linear, negative and linear. It's very easy in these examples to see where the trends are in the data, right? So people use these approaches to talk about trends, to talk about relationships in their data. And what if you've got no relationship? That's also something that might be important to present with a scatter plot, also as in this example. We're going to talk about tables again in a moment, but summary tables are fantastic ways to, as we talked about earlier, present your data as an overview, summarize all of the data that you collected in a particular study, recording how often each value of each variable might occur. And these are built by identifying upper and lower limits in your data. Numbers of classes, for example, and their distribution, their width. Segment the data out within those classes, and then all of your values in your data collection should fit into one class. So here you can see some examples of how it can work. I counted up my friends and put them into frequency parts of the summary table. So do have a look at that. As we mentioned earlier, everybody listening to this event today will get access to a recording. So don't worry, you'll be able to listen back and have a look at these slides in your own time a little bit later. We've seen box and whisker plots a lot, especially in quantitative research. Here's one that gives you the distribution of guinea pig tooth growth as a function of vitamin C dosage. And this tells you where the data distribution is, as well as with a confidence interval on the ends of those distributions. So these are also effective ways to present your data in order to get your message across. In this example, we're showing how growth in teeth is relatively or not so relatively related to the kind of diet that the guinea pigs have been exposed to. So have a think about these as well. And visualizing correlation, as you saw in the scatter plots we presented earlier, can also be very, very useful, because if there's a linear relationship, then an R of 1. And you can see here on these examples, as the data gets less and less correlated over to the top left-hand side of our slide, as we visualize the relationship between variables in our data. But be very careful, of course, with correlation versus causation, because correlation does not imply a cause. As you can see in the joke example on the right-hand side of this screen, we are looking at a measure of linear relationships only. And there could, of course, be a misleading influence of a third variable. You might be looking at spurious correlations and combinations of unlike populations. So be careful when presenting data in this form. You're looking at relationships, but there might not be necessarily any causative relationship in your data. Least squares regression are one of the most common approaches used to demonstrate correlation in data sets. We can talk about this in our Q&A at the end, or do get in touch with us, as we mentioned, if you need any additional help with developing a statistical approach for your next study. That's the ways and examples and things that you can think about when putting your data presentation together in section 2 of our short webinar presentation today. Let's have a quick look at topic number 3, one of my favorite bits of all of the webinars that we do together, Scott and I, 10 simple rules for making effective figures. These come out of an absolutely fabulous paper, Rougier and colleagues, 10 Simple Rules for Better Figures, published in 2014 in PLOS Computational Biology. So if you haven't got a copy of this, do get a copy of this. It's absolutely fantastic. It presents for you in one place things to have in mind when putting data presentations together, when putting together figures to show your data to the world. Rule number 1, know your audience. The way that you present, as you can see here in this example, cancer death rates will be different depending upon your target audience. If you're talking to other doctors, you do it in one way. If you're talking to members of the public, you do it in another way. So as we've already talked about earlier in our event today, first rule for effective data presentation is knowing your audience. Second rule is identifying your message. What is it that you want to get across with the data that you're analyzing, with the data that you're presenting? Because if you don't know that, you will not make an effective figure. Rule number 1, identify your audience. Rule number 2, identify your message. I believe we've touched on these at the beginning of this presentation. If you cast your mind back to the beginning of our webinar today. Rule number 3 is, of course, adapting to the medium. The way that you would present information in a talk at a conference or in a poster at a conference will be different to the way that you will present that in an academic research article. So, for example, simpler might be better in some media, whereas you can be more complicated if you've got a bigger screen or if you've got a media where people are able to interact more with your data. So that's rule number 3, making sure that you're aware of your media. 4 and 5, absolutely critical. Your figure captions are key. Keep in mind that most people, when they read academic papers, they read them on their phone or on their computer, more and more on their phone, and they're clicking in 2 different parts of your academic research article, like the figures. And that's going to pop up. They're going to read the figure caption. That's got to contain enough information for them to understand what's the figure about so that they don't have to read the rest of the study. Great example of how this can be done is by looking at Nature and Science articles, because they really have cornered it in terms of putting effective information into figure captions so that readers can understand and feel what the figure's about, what the figure's showing, without having to read the rest of the study. And of course, be careful about your software. I always used to be pushed towards certain kinds of software packages when I was a student that I had no idea how to use. Make sure you are using software to make your figures that you are happy with and you are comfortable with. Rule number 6, color. Some people are colorblind. They might not be able to see the same trends in your figure that you can see. It might be easier not to use color at all, as you saw on some of the earlier examples in this presentation, the histograms, the box and whisker plots. Color is not needed in those data presentation examples. So use color effectively to get your message across. Maybe make multiple versions and ask people in your department, in your research group, which is better. And Scott's going to come back now because we've got another poll for you about these graphs that actually present the same data, but in 2 different ways. Scott, how are we doing?
Great. Thanks, Dr. Dyke. We've got one more poll question for you. Let's see what our audience thinks of this one. So question number 2, let's launch the poll. The question is it ethical to adjust the scale of a graph to make my results look more significant? Let's see what our guests think. Do you think, yes, this is ethical practice, such as the example you can see on the slide here? Or do you think, no, this is not ethical? Let's see what our guests said.
Yeah, keep in mind that these 2 examples that we're showing you on the slide are of the same data, but presented in 2 different ways. And I think you get the impression from each graph. You get a very different impression from these data, depending upon whether you look at the black graph or the red graph. Is that ethical?
Okay, most of our answers are in, and looks like our audience was fairly split on this question. 56% said no, it's not ethical. 44% said it is ethical. Let's check the answer. Dr. Dyke, what do you think? Is this ethical practice, this kind of scaling to enhance results?
Absolutely not, unfortunately. And this is something that reviewers will check. And people, when they read your paper and have access to your original data, will also be going back and looking at. I mean, if you're publishing a paper based on a certain data set, you're going to be sharing that data set with your audience as well, online or as a supplement, to your study. So people are going to go back and they're going to check it. And so you want to make sure that you are presenting those results in the clearest, fairest way, because you don't want somebody writing a snitty little reply to your paper saying, oh, well, actually, if you present the results in this way, you get a completely different outcome. So reputation-wise and also ethically speaking, don't adjust the scales on your graphs to make your results look more significant, as you can see on this example here, right? All right, cool. Let's move on. Fantastic stuff. Rule number 7 is don't mislead. That's what our poll that we just ran was all about. Don't present your data in confusing ways in order to make them appear more significant. So what they've done here is they've talked about the relative size of a disk area in black and the relative size using disk radius in red. And as you plot the red data, as you can see, it looks like you've got a much more significant change than you might actually have. So don't do that. Don't mislead. Rule number 8, you don't want junk. And this is a good example of why you might not want to use color in some of your figures, because the junk version, the difficult to understand version, the confusing version is there on the left-hand side. But I think you'll agree that on the right-hand side, I've actually got a much more easy to understand presentation of my data. You can see the 7 data series and you can see what's going on with them over time much, much more easily. Message over beauty, of course. You don't have to be Van Gogh or Picasso or the best in the world at creating amazing looking figures. As you can see here, what's actually critically important in research articles, as we've been talking about throughout this event today, is getting your message across. And of course, as well, goes back to the point we made about software a little bit earlier on in our presentation. Get your hands on a tool that works for you and that you can use and that will lead to a consistent presentation of figures, of tables in your work. So when people look at the work of you, Gareth, or whatever over the next few years, they'll see a consistent style in the way that you present your data, the figures that you make. That is also very, very, very important. So that was topic number 3. Moving on quickly at the end of our event today into topic number 4. I know you've been waiting for it because tables are probably the most exciting part of data presentation of all. So let's have a quick chat about tables. These, as we've talked about earlier, are probably the easiest way to present data, although I've seen many papers where there are just endless tables of data, and that's not what you want. A lot of that could be in the supplementary information. Think about how you can use tables to present and summarize your findings so that readers don't have to struggle to find information. Go back and have a look at the summary table examples that we showed earlier in this presentation. You should use a table if showing a trend in your data is not important. If there are not too many numbers, summarize your data in a table and use these to complement other data presentation formats. Complement other presentation formats. So don't fill your tables with grid lines. Remember that we read from left to right, not from right to left. We go from the top to the bottom. You want increasing size in your data as you move down the table. So there are a number of principles that you can see on this summary slide here that we do hope you'll find useful when you review this presentation, when you come to put your data together in your next academic article. So what to include? For example, when we look at numbers that make up the population of Wales, which is one of the constituent parts of the good old United Kingdom of Great Britain and Northern Ireland, there you have population numbers to a number of significant figures, which might not necessarily be what you actually want to present in your article. Sometimes, as you can see here, a simple table is better because your readers will much more easily get the information that they need out of this kind of presentation. My goal is just to demonstrate that the population's been increasing. So I don't need lots of specific significant figures. And here's that simple relative frequency table that we showed you a little bit earlier. Coming back again, what we are going to do is provide a simple summary of the key data in the paper that we're then going to go into in more detail in subsequent parts of the results section. It sets the scene. Very good way to kick off your results section. Very good way to get things going at the beginning of the event. Now, complex tables often are included in academic studies, but is this clear? Is this good? Is this the best way to get your data across? Have a think about how you might want to be presenting your message and whether this should be a presentation in the main body of your article. Sometimes it's necessary, but often these kinds of complex tables can be presented in data supplements where people really interested can access them, but not everybody reading the paper. So that is important as well. I'm sure you can spot the multiple problems with formatting in this example. There are many. You need to make sure that your tables are simple and easy to read and easy to follow. Who's your audience? What are you presenting? What do you wish to show? We recommend that you make a format, a template that you can reuse in subsequent papers that you publish in your field. Perhaps you're publishing lots of papers in one particular journal, or there's a formatting style that can be easily modified depending upon the kinds of journals that you're publishing your work in. Make a template. You can use that in your work in the future. And don't forget that histograms, graphical representations of frequency tables, these summarize categorical, nominal, and ordinal data, very useful when dealing with large data sets and can be used to demonstrate to your audience outliers and gaps in the data. Which brings us to the end of our presentation today. And I'm sure we've got some questions and some time for questions. Don't forget, if you'd like to get access to all of the fantastic Bentham journal collection, have a scan of the QR code here on the screen. And with that, I'll say thank you very much for listening and hand back to my dear colleague, Scott. Scott, how are we doing? Everything okay?
Everything's great. Thank you, Dr. Dyke, as always, for sharing your insights. I always learn so much from joining these events with you. And we do have some questions from our audience tonight. A couple of very good questions. Here's a question, if we have time, Dr. Dyke. Here's a question from Satyajit. I'm sorry if I'm not pronouncing that well. And the question is, which are paid and free tools to generate scientific figures? Well, there's a whole host of them. Are there any chosen tools that you tend to gravitate towards, Dr. Dyke, for generating figures?
Yeah, we're going to follow up on that question with all of the participants, and I think we should include that in our follow-up email. We do have a big list of those, far too many for us to go through right now. But yes, what we'll do is we'll send that as an attachment when we send out our follow-up email from this webinar. That's a great question. Thank you very much for it. Yes, lots is the answer. Very many. I see another question about R as well. And that's also a good question. Like, a lot of people do use R to reproduce and make figures. We will point you also to some resources and courses and training around that particular statistics software package as well. So thank you so much for that great question also.
Great, excellent questions. If you have any other questions, feel free to either type them in the Q&A window or in the chat, and we'll try to answer them now. We've just got a few minutes left for today's event, so don't be shy and feel free to ask us a question.
We run webinars every month. Bentham has a webinar series. We'll put the link to the place you can go to see the other webinars that we're running into 2024. We're in the process of updating our schedule with Bentham for our webinars for 2024, but once 2024, I can't even say it, but you can bookmark that link if you're joining us today, and then we'll update you, and then you can join our webinar series with Bentham Science, because I see that there's a question in the chat about ethics training. Yes, we have recordings. Yes, we'll be doing future live events on research and publication ethics. So follow us on all of the different Bentham social media channels. You can see them here on the screen. Get in touch with us. Have a look at the Bentham webinar page. Re-listen to this event. Get in touch with Scott and I if you have any follow-up questions, or we can provide you with any support and help.
Great, and we'll definitely let you know when events are coming up. If you have joined our email community by joining this event, of course, we'll let you know when future events are coming. And we've got another guest asking us similar question: software to generate figures that are aesthetically pleasing. Yeah, again, we can recommend several for you, and we'll follow up after this event in our follow-up email, and we'll suggest some software tools that you can use to generate figures.
Absolutely. Absolutely. Fantastic. Fantastic. Great stuff. I think we're almost done. If there are no more questions or comments, thank you all for joining us. It's great to be here. Thank you so much.
And thank you, Dr. Dyke, as always, for sharing your expertise with us. And to everyone who joined us tonight, on behalf of Bentham Science, we were so happy to be here with you tonight, and we wish you the best for the coming holidays. And we look forward to seeing you in our next event with Bentham Science. Thank you, Gareth, and thanks, everyone.